In this video, I'm going to talk about the electrical activity in the heart and the ECG recording, and I have pasted the bipolar limb leads electrodes, which is your combinations of your positive and negative electrodes, and you have leads 1, which is in this. Leads 1, which is the positive electrodes on your left arm, and the negative electrodes on your right arm. This is leads 1, and this would be leads 2, the combinations of leads 2, and this would be the combinations of leads 3. Okay, in this case, I'm going to talk about why the patterns in different leads records different patterns in terms of their wave, in terms of their upward, the degree of upward deflections, and the degree of downward deflection. So first thing, you have to recognize that different limb leads, they record the electrical activity of the heart at different angles of the heart. So that means they view the electrical activity of hearts at different views because they are placed at the different parts of the body. And why you place the electrodes in the arm instead of the shoulder? Because you have more muscular on the shoulder, and we do not want the skeletal muscle to disrupt the electrical recordings in our ECG. So what we do is we just place in the less muscular area, which is our arm and our ankle. So in this case, I'm going to use electrical recordings using the ECG to show that why ECG will show an upward deflections and why sometimes it shows a downward deflections. So in this case, first thing you have to recognize before you go into the much detail is that the wave of depolarization is moving towards the positive electrode. Moving towards the positive electrodes, this will show an upward deflection. And if the wave of depolarization moving away from the positive electrode, it will show a downward deflection. And remember that positive electrode is the recording electrode and negative electrode is the reference electrode. So in this case, I'm going to show you the sequence of events that occurs in our heart and the sequence of depolarization. For first thing, you have to know that action potential propagated from SA node, in which SA node is your pacemaker cell. It's a collection of specialized cardiomyocytes. So this SA node has the pacemaker potential, and it is the dominant pacemaker in our heart. So the wave of depolarization, as you can see, from SA node, which is near the entrance of the SA node, near the entrance of the superior vena cava, and the wave of depolarization will propagate towards this direction, here to your atria, and to your AV node. So in this case, as you can see, the propagations of the depolarization wave. So let's say we take a look at your limb leads 1. The propagations of the wave of depolarization will be pointing towards your positive electrode. So in limb leads 1, it will show an upward deflection. In this case, is your atrial depolarization SP wave. So how about your limb leads 2 and limb leads 3? Same thing will happen because your wave of depolarization is pointing this direction. And if you take a look at your limb leads 2 and 3, which is the positive electrode at the left leg, you can see the pointer are pointing towards the positive electrode. So in this case, your limb lead 2 and 3 will also show an upward deflection. Okay, so now we move on to the AV node. So for the AV node, the wave of depolarization will first reach your left septum. This is just because this is due to that your left bundle branch has smaller branches that innervates your left septum, but there is no smaller branch that branch out from your right bundle branch. That's why the wave of depolarization will be moving towards this direction. That means your left septum will be depolarized first, followed by your right septum in this direction. So as you can see from here, in this direction. So what happens is that, as you can see, in your limb leads 1, let's say you take a look at your limb leads 1. So if your wave of depolarizations is depolarized from the left side to the right side, so the wave will be moving into this direction. So what happens if it's moved into this direction? It moves away from the positive electrode in your limit 1. So that's why your limit 1 will show a downward deflection as a small Q wave. Okay, as a small downward deflection Q. Okay, so this is just essentially the same thing as your limit 2 and 3. So they might is still pointing away from them. It's not pointing towards them, it's pointing away. So limit 2 and 3 will also give you a downward deflection, but there's a condition that the patterns of the downward deflections, the Q wave, might not be appear in the limits if it is not that obvious. Sometimes it's not that obvious, sometimes the Q wave just not there. Okay, it depends for the Q wave. But for R wave means you have the so R wave we are referring to the depolarization reaches the wall of the heart. So what happens is that your wave of depolarization from your septum will go to the heart through the conducting system. So the wave will be pointing towards like that, like that, like that, like that, and like that, and like that, and like that. So what happens is that you will have the net wave of depolarization direction towards the left side of the heart. Why? Because your left side of the heart is thicker and it comprises any more. So the net of depolarization, your net vector, will be pointing towards the left side of the heart because your left side of the heart is thicker. So what happens is that, as you can see, it is pointing towards the limit 2 and 3 positive electrode. So we'll show an upward deflection as your R. So it's a big upward deflections in R. Why? Because your left side of the heart is thicker, so the depolarization is more, right? So the deflection is even more. So same as your limit 1, it will also shows the upward deflection because we are still pointing towards the positive electrode of your limit 1. Okay, so the depolarizations will finish at the right ventricle first, then finally ends at your left ventricle. Because your left ventricle is thicker, it take longer times for your left ventricle to depolarize finish. Okay, so when everything is done, when the depolarization is done, is finished, that means all your extracellular fluid surrounding the heart is negatively charged, completely negatively charged, and there is no potential difference in the extracellular fluid. So it will record as a baseline, which is horizontal line, or what we know as the isoelectrical line. So that's all from me. Thank you so much. I hope you enjoy it. But before that, I just want to make a summary. So you just have to remember the wave of depolarization from SA node to your AV node to your atrial is through this direction. The depolarization is just to this direction. So when you want to take a look at which limb leads, then you just see this vector pointing towards which direction. So for SA node, from SA node to AV node pointing to this direction. So go towards the wave of depolarization, go towards the positive electrode, give you an upward deflection, and the same thing in this positive electrode too. And then when you go to the septum, which is the first part to depolarize, and you can, as you know, that there is no small branches to your that supply that innervates the right septum, so the depolarization wave will be moving from the left septum to your right septum. And can you see the vector is pointing away from the positive electrode? So the positive electrode from your limit 1 and of course your limits 2 and 3 because they're pointing toward this side. And then when you go to the ventricular walls, you will have the net of depolarization towards the left side of the heart. Why? The net vector is towards the left side of the heart because the left side of the heart is thicker. So it's pointing towards the positive electrode, is pointing towards the positive electrode, and also with this positive electrode. Okay, that's all. Thank you.